In this presentation, what we're going to do is use the ratio test to test this series for convergence. Essentially, I just sort of chopped a bit out of the question, but essentially what I have here is the general term for the series. U of n equals n factorial times n factorial over 2n in brackets, so 2n factorial. So just be careful about that. So if n is equal to 4, what we'd have is 4 factorial times 4 factorial over 8 factorial. Okay, so it's it doesn't cancel out easily, if you get me. Okay, so 2n factorial, so it's 8 factorial. So the first thing we're going to do is calculate u of n plus 1. So I have the job started here. U of n plus 1 equals n plus 1. So just I put in u of n was n factorial times n factorial over 2n factorial. Okay, I'll just put that in brackets. So just the next number up is 2n. So I've made a little mistake there, and let's just be very careful about it. That actually should be plus 2. Okay, when I replace n with n plus 1, I have to be very careful the whole way through. Okay, so just be careful about something like that, and I plowed straight into it myself. When we're replacing n with n plus 1, just be careful about multiplicative terms. So 2 times n plus 1 is 2 n plus 2. Just be careful about things like that. I just like sort of plowed straight into it. Now, what we're going to do here is rewrite a couple of these terms. So n plus 1 factorial, that can be rewritten as n plus 1 times n factorial. Okay, so far so good. 2n plus 2 factorial can be written as 2n plus 2 times 2n plus 1 times 2n factorial. Okay. Now, the reason is why we're going to do that is because what we have to do here is compute this expression here. Now, the u of n plus 1 over u of n. Okay. So what I'm going to do here, you don't really need the absolute value indication here, the parallel lines along either side is the absolute value. But what we do need to remark upon is 1 over when we divide by u of n plus 1, that we can actually write that as u of n plus 1 times 1 over u of n. Okay, or essentially what we do is get the reciprocal of u of n. Okay, so let's do that now. So u of n plus 1 is what we have, n plus 1 factorial times n plus 1 factorial all over 2n plus 2 factorial. Okay, that is u of n plus 1. Now what I'm going to do is have 1 over u of n, and essentially I'm just going to multiply above and below, or sorry, just change the numerator and denominator. So what I have here is n factorial times n factorial. That's the numerator of u of n, and the denominator of u of n, what we put up here, is 2n factorial. Okay, quite a complicated looking expression there. That's a multiplication sign. But what we're going to do is start cancelling bits out. Now, so n plus 1 factorial is n plus 1 times n factorial. Okay, so what's going to happen here is that if I express n plus 1 factorial as n plus 1 times n factorial, I can get them to cancel out. Okay, so that cancels out with that, just leaving n plus 1. Okay, I'll put that in here actually. Just get rid of that. This cancels out with this, leaving also n plus 1. Okay. This cancels out with this, leaving, I'll just get rid of that, also 2n plus 2 times 2n plus 1. Okay? Now, so what we're left with is when we go through all these cancellations, and I'll just sort of be clear where all these cancellations are coming from, particularly this stuff here. Okay. So if we just sort of tidy that up, what we would get is n plus 1 times n plus 1 over 2n plus 2 times 2n plus 1. Okay, and what we could do now is also actually just express that as a polynomial. So we have n squared plus 2n plus 1 over 4n plus, let's see there, we would have 6n plus 2. Alright, yeah, okay. So when we divide that down, we would get 4n plus 2n plus 1 over, n squared plus 2n plus 1 over 4n squared plus 6n plus 2. Now, the ratio test asks us to compute this limit L, which is the limit as n approaches infinity of u of n plus 1 over u of n. Okay, so for us, that is the limit as n approaches infinity of n squared plus 2n plus 1 over 4n squared plus 6n plus 2. Okay, and what we're going to do here is use just general rules for limits. We're going to divide the entire both the numerator and the denominator of what I have there by the highest power of n. That is n squared. So 1 divided by n squared, n squared divided by n squared gives us 1. 2 divided by n, 2n divided by n squared, 2n over n squared. That will give us 2 over n plus 1 over n squared. 4n squared divided by n squared is just 4 plus 6n over n squared. That gives us 6 over n plus 2 over n squared. Okay. So the limit of that expression there is essentially all these terms cancel out to 0. Okay, as n goes to infinity. So what we're left with is a limit L, or a limit L is 1/4. Okay, so if L is less than 1, series is convergent. Great. Just as a remark, so that's the answer. It is convergent. Show it's convergent. L is the limit is 1/4, and that is, we know how to interpret that. L is less than 1, so it's convergent. The other possible options were L greater than 1. It would have been divergent. That's not the answer in this case, so we don't have to worry about that. Sorry, that's L greater than 1. L equal to 1. Inconclusive. Now, we didn't get that either. Okay, we got the conclusion we were looking for. L is 1/4, so this series is convergent. So that's the ratio test.